Okay, hello everybody. My name is Fadil and this is my final project. It is about homemade French fries and the nexus of water, food, and energy related to the homemade French fries. Why I choose French fries? Because I love them and they are everywhere. According to the USDA, the fries helps boost the away from home vegetable consumption for American people over the past 2 decades, but none of them has influenced the increase more than the frozen French fries. So processed potatoes in large amounts and like French fries, it accounted for 27% of the growth of the total vegetable consumption since the 1980s. So consumption of the potatoes as fries increased 50%, and it's around 58 pounds per year according to the USDA. Even though potatoes are generally consumed as chips, but 88% of them are consumed outside the house. So what I am talking about now is about that 12% that is made at home. So my project is about the French fries, and simply as I make them at home, it's three components only, or that's what I saw. And it's salt, that is sea salt, oil, that's from oil crops, and potatoes that are from potato farms. Usually it's from Idaho. It can be any other different source. Where does each component come from is really what take most of my research time. Because depending on where each component comes from and its journey from the source to the table or to the end user, which is me in this case, it would have a different footprint in water, different footprint in energy, different footprint of carbon emissions and resource use. Even the fine details of processing it at home make a huge difference, even in landfills and land use, which is I tried to demonstrate in during this. I would like to start in the beginning of the sea salt harvesting or sea salt sourcing. Where does the sea salt come from? So sea salt, as its name indicates, it comes from the sea. Now the process of getting it is a very traditional, simple process. All what changed in it during the years was the technology used, and this what led to more energy use and more manufacturing use, more water use. But basically, seawater is pumped into evaporation ponds, and those ponds evaporate with time, and then the soil is piled and harvested, then it's milled, and then it's packaged, and then it goes to the market. As you see in the next slide, I tried the pictures. Some I sourced from Google, some I really took myself, but but from the sea to the house, if you see here, starting from this here, those are the ponds that the seawater is pumped to, which is uses so much energy to pump, basically diesel. Then the salt is piled, then it's transported with big heavy machinery that needs so much water and energy to operate and to use and maintain, and its parts, and it use even the world trade to get them working. Then it's shipped to the mills, then it mills into different grades, then it's packaged, different packaging thing, then I put it on my fries. You would think a little bit of salt would do nothing, but it's a very big industry. Soil works all usually are in places where the water has around 2.6% of salt on average, and types of salt are harvested differently, and the times of evaporation depends on the heat and humidity. But most companies argue that the packaging is what really consumes there. If you look at the environmental impact of sea salt harvested by evaporation or from evaporation, it includes all the construction and causeways and evaporation ponds, barriers, equipment, storage sites for tailing materials, and other physical structures of a vehicle commute that needs the operations by itself, like doing the ponds and the high concentrations of salt, is a discomfort of the region and it destroys the area around their sources. So the land in the salt harvesting area is damaged forever because of the heavy machinery and the high concentrations of salt over the harvesting years. The ecosystems and plains are damaged and dead. The CO2 emissions differ according to the equipment used, and shipping distances and packaging are what really involved in direct use of energy and emissions of CO2. Most companies argue that their water footprint can be neglected as they use the salty water from the sea or from the source, and they then evaporate it, which is goes into rain and stuff. So it doesn't evaporate salt water; it evaporates fresh water. So they argue that, well, it's a good thing that they do that. Then you have the second component for me is the oil. And processing the oil is a very big thing because it's a farm, like all and potatoes are farm products. So as known that the farm products use so much water, so much manufacturing, so they have so much waste. But in general, the land preparation for planting includes tilling, pesticides, herbicides, and treatments. Then planting the corn. When we plant all the corn seed supposed in the U.S. supposed to be treated with at least color to distinguish it from the feed corn and from the other corn. And when it's planted, heavy equipments are used, many chemicals are used. I didn't go into through all that because it's too much. Then you have, after the seed is planting, you have the fertilizing and irrigation. Like fertilizing, corn is a heavy feeder, and producing the nitrogen fertilizers need tons of water and diesel and stuff. So the corn needs 1,222 liter per kilogram of corn. So it needs that much of water, and 77% of it is green, which is the rainwater, and then 7% is blue, and 16% is gray. Then you get the harvest. Harvest is mainly a use of and heavy machinery and diesel included. Now, to process the corn into oil, we come to the milling part. You have to mill the corn and do it into a grade so you can take that and press it to extract the oil out of it. Now, extraction of the oil would be first mechanical to get rid of most of the oil that can be got rid of. Then we use solvents like alcohols to do that. Now, to clear the oil from the solvent, we do a process called desolventizing, and desolventizing requires a huge amount of energy because it depends on heat. We heat the oil or the flakes that remain from the extraction, and all the solvents evaporates faster than the oil, so the oil is separated from them. Then you get the crude oil, and we go and process it Processing it means clearing it from the gums that form because some of the fatty acids. Then we neutralize the pH, then you bleach it, then you remove the odors out of it because milling, as I will tell later, milling is a very lengthy process. Then packaging, which mainly it's you have to have a good package that doesn't leak oil while it's on the shelf and maintain the quality of the oil. Mostly they are plastic, which is requires too much energy. Then you distribute to the stores, so you're affecting the shipping and the mileage and the diesel burn. Then it reaches home where we use it in our product. Now all this process is very complicated. In the beginning of it from here is the same as for potatoes. It's just the change of the amount of water needed. The nastiest part is the milling. I will tell that later. And I go to the environmental impact, which is the milling. So environmental impact, corn wet milling operations are source of the sulfur oxide, which is a very bad smell. It's like rotten eggs and organic volatiles emissions. But data is insufficient to characterize according to the USDA or quantify those emissions. Now, sources of VOC are identified, so they use some kind of filters to try to reduce the emissions. So although no data is available to quantify them, how much they are, because of the variation between place to place. The variability of the process between facilities made it difficult to gather data. Most tables that are from the sources I found, they're marked as ND, which is no available data. And then a lot of energy in the process of corn. Includes the heating to temperatures around 1000 to 1400 Fahrenheit. And then you have the shipping involved and the fertilizer production. So that greenhouse gas emissions, according to what I've been able to find, are to vegetable oil and crops are as much as 5 to 25% of higher than the other agriculture crops. This is from 0 acres. Those are some operations of the farm. Now, I read a lot from Iowa State University about the energy used in the farm. So most of the energy is used in transportation, farming, tilling, spraying, harvesting, transportation. All of it is used diesel, and they say diesel is like a main source of spending, and but it's very necessary. Those are pictures for some of the operations. You can see some of the dust during harvest. You can see how big the equipments are. You can see the trucks for shipping. Plus, add to all that manufacturing, you have the fertilizer production, which, as I mentioned, is too much of diesel equivalent. Like some of the studies says that it could be equivalent to 21 gallons of diesel per acre. Potatoes as a crop too is a farm product, and it includes land preparation and planting and then fertilizing and irrigation. So in total, it is assumed that 287 liters per kilogram is needed to produce kilogram of potatoes. You need 287 liters. 66% of it is from the rain, which is considered green. Then you have the 11% blue and 20%. The average burn is 4 to 6 gallons per acre of diesel, and this is for all farm operations. And the sad part is 40% of the potatoes is what reaches the market. The other ones are really damaged during harvest, or they are in the bad size, bad shape, so they go to barriers and they are buried, so they don't really reach. So from here, after harvest, you go to washing and sorting. This is where most of the potatoes are get rid of. And then the packaging, it depends on the customer use. So if you want them frozen, if you want the fresh ones, it all depends on the end user. Then it's distributed to the stores, then from distribution to the house. The environmental impact of producing potatoes, they require 100 to 100 pounds of nitrogen fertilizer per acre. This is equivalent, according to Iowa State University, it's equivalent to 21 gallons of diesel burning. Now, many of the potato producers use plastics for irrigation, mulching, row covering, and fumigation. Like other vegetable crops, pesticides and fungicides are used in the herbicide. One crop is used in a large acreage and is planted with one crop all the time. Storage of potatoes requires ventilation and suitable temperature and very low humidity, and this requires energy to maintain. So preparing the land and planting and shipping and harvesting, this is all uses a lot of energy. So to the nexus, I put the planet Earth around the food, water, energy nexus. So in theory, if you want to plant more food, you want to plant more land, but you can substitute the land with using chemicals and fertilizers and other irrigation methods that will consume more energy to produce. So if you want to save energy, you would consume more land. Now, producing other petrochemicals and other heavy machinery, you would need a lot of water. And planting, if you need irrigation, you need more water. So either you use more water or use more energy or use land or use food. The more food you want to produce, the more energy you want to use, the more water you want to produce. If you want to go organic and reduce less chemicals, you would have need more land. So more land means more work cultivating that land and preparing this land. So it's like a never ending circle. So it takes around 2000 liters of water to produce 1 kilogram of oil for the crops to fry the potatoes. Then it needs 283 gallons of water to produce 1 pound of oil in moderate footprint. So the energy is also used production steps. Many of the energy is ignored because it's considered out of the farm, and transportation takes a lot of the diesel. Sources of waste in making fries is basically the milling of more of corn in preparation for extracting oil, procedures of the farm and the mass production, shipping months, packaging of the product, processing the potato to become fries in the house, peeling, cutting, and getting rid of the used oil. Suggestions to reduce waste. I would, according to my research, buying local. It reduces the distances of shipping at least, and it reduces the nitrogen oxides in the sky. Make fries at home because you can choose the type of oil that more environmentally friendly, or you can use the type of fryer instead of the frying pan, the regular. Keep the peel because the peel is very nutritious, so and it wouldn't harm you if you wash it. Do not use disposable and use the amounts that you. Some pictures like I have a glass plate versus the paper plate. Um, I have frozen versus the regular. Like the frozen ones, the packaging contains very much less amount of potatoes, so you have more packaging, more storage energy needed, while the fresh potatoes are usually in one bag or mesh screen, or they are trying to do the paper bags, so it would reduce a lot of use of footprint. Even the salt shaker, I found out it makes a big difference. This one here, it has a battery and the light and the engine and the motor and so it has a very big water energy print and even minerals like a lithium battery you may need. This one here is a regular salt shaker. Gas or air fryers use 1 tablespoon while regular frying use. Thank you, and this is my project. And these are my references. Bye.